Hey everyone, welcome back to the channel. This is Rahul. In today's video, we are resolving another lead coding problem, that is find the punishment number of an integer. Actually, is an easiest one, but little bit tricky. We will cover the problem statement and we will break down the approach. Later, we will do one efficient Java code and we will explain about the complexity analysis. At last, we will explain why this solution is efficient than others. Now, let's get into our problem. So, here is the problem. You are given a positive integer n. Here, you need to find the punishment numbers of n, which is defined as the sum of the squares of all integers I, such that 1 less than or equal to I less than or equal to n. Here, the decimal representation of I star I can be split into contiguous substrings such that the sum of these substrings equal I. So I will just give you one example here. Uh, let's take the number 45. So this is our I. We can use I star I 45 star 45, which gives 2025, isn't it? Now we can, as I mentioned, we can separate into substrings and we can sum that such that it will become the I. So here 20 plus 25, which gives 45. So this is the way we can write. Another one is 9. Here 9 star 9, which gives 81, which can be given as 8 plus 1, which will be same as our I. So this is the pattern we have to do. Means we want to sum up all squares of integers that meet this condition up to n. If we get a value 10 or 100, as you can see, here it's 10, we have to do all the elements that satisfy this condition inside that one. Okay, so let's start. For this, instead of recalculating and checking each numbers manually, we have a pre-computed list of numbers that satisfy the given conditions, and we iterate through the list and sum the squares of numbers that are less than or equal to n. You might be thinking why we use a pre-computed list. So checking whether a number satisfy the condition requires partitioning the square into substring and summing those substrings, which can be slow. By pre-computing valid numbers, we avoid repetitive calculation and speed up the solution. So if you go down here, it's they given one constraint like 1 less than or equal to n less than or equal to 1000. So here we are using one list that is 1 from 1000. What all satisfied elements are there, we will use, and I will show those elements. Only these elements will satisfy those condition. Okay, so let's start. Int array, and this is our list 1 9 10 36 45, like that till 1000 we are given. Here this contains number satisfy the condition up to 1000, which this array will compute using this punishment number method that checks all numbers up to 1000 for the substring condition. As I already mentioned, we already have the constraint 1000, that's why we stopped at 1000 here. Now we have to calculate the punishment number for a given n. So first of all, we have to initialize the result variable. So int result is equal to 0. Here this will hold the sum of squares. Now I need to loop through the array, uh, iterate through the numbers in the pre-computed array. So for int I is 0, I less than array dot length, then increment I. Once this done, we have to check if the current number is less than or equal to n. If array of I into n, then we have to add its square to the result plus equal to array of I star array of I. Okay, here this adds the square of the current number to the result. Okay, once this done, come out of the if, we have to give one else condition also, means if the current number is greater than n, we have to stop the loop early, which means this will avoid unnecessary iteration. Okay, now at last we have to return the result, means the calculated punishment number. Okay, just run it. It's working. So using a pre-computed list is more efficient because checking the partition condition is low. Each check would involve recursively splitting the numbers and summing substrings, which takes a lot of time. So pre-computing these numbers allows to solve the problem in constant time for any number up to 1000. So submit it. So you can see it's taking 0 ms only. This is the most efficient code because the time complexity is big of 1 here for the given array size, means we only iterate through the pre-computed array of size 29, and space complexity is big of n because the array size is fixed, we didn't add anything extra. Now let's compare with brute force. Actually, a brute force approach would involve checking every number up to n, calculating its squares, and recursively splitting the squares into substrings. This would take exponential time, and as you know, it will make it slower for larger inputs, as our pre-computation based approach is much faster and more efficient. So that's it for today's video. We covered find the punishment number of an integers problem, walk through an efficient solution using pre-computation, and discussed its complexity. If you enjoyed this video, please like, share, and subscribe for more coding content. See you in the next one. Till that, happy coding.